Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to All About Lines. One of the most important things that we're going to notice with a line is how steep it is, and we can compare different lines at that. The steepness of a line is also known as the slope. Many of you have heard about change in x and change in y, right? So the change in y compared to the change in x. Or another way of saying that is delta y compared to delta x. And we see that some more in other books, for example, science books. We might see the delta for change in. We might have also read it as rise over run. Or y2 minus y1 over x2 minus x1, or even y1 minus y2 over x1 minus x2. And usually slope, we abbreviate it with the letter m. One important thing to know is that we normally read our slope in terms of going from left to right. So a positive slope would be starting down low and moving to up high. So keep in mind that when we read, whether it's positive or negative, we're more thinking of it like a vector. I know it continues in both directions, but as we move left to right, this would be a positive direction because it's going up. Or you can even think, hey, this ends in the positive y value. So therefore, this would be a negative slope. Now, every line has some kind of steepness to it, so you can't say no slope. So I usually think about the next two as like sledding. So yes, this would be no fun to sled on, or zero fun. So this is a slope of 0, and that's because it does not go up, it does not go down, right? It has 0 rise. And then if this were a massive, massive cliff, and you were to try to sled straight down a vertical drop-off like this, you would be undefined at the bottom. This is an undefined slope. It's not no slope, it's an undefined slope. And the reason why it's undefined is when you subtract your x's, you get 0 for the denominator, and you cannot calculate a division by 0. So anytime these are graphed, this would be graphed as y equals your value because it's going to cross the y-axis somewhere. This is going to be graphed as x equals a value because it's going to cross the x-axis at some point. This is also not a function. Every other line is a function except for a vertical line. So please keep that in mind. So if we have P is at 2, 1 and Q is at 8, 5, we could calculate the slope. Now some people are going to need a rough sketch. 2, 1, 8, 5. We can definitely see that it's going up in between those. Could you count like north and over? Yes, we'd have to go up 4 over 6. So 4 over 6. That's a very literal over. Or if we're using the formula, y minus y. Now, if you start with 5 on the numerator, you have to start with 8 on the denominator. So over x minus x. And we do get 4 over 6, which reduces to 2/3. So our slope is 2/3. Please always reduce them. Now, just to prove a point and to prove that it doesn't matter, what if I had done, instead of 5 minus 1, what if I had done 1 minus 5? Well, if I do 1 minus 5, I have to do 2 minus 8. And I get negative 4 over negative 6, which is still positive 2/3. So that's okay as well. So can we put them down and count? Yes. It's your up, down, and then over the run. So I do like to keep that in mind. And from there, usually you're going to get an equation of a line. And I know a lot of students use y equals mx plus b, which is not my chosen method. So the reason why it's not my chosen method has a lot to do with calculus and. So please keep a quick eye on what I'm going to show you here. So we know that we can calculate slope by doing y minus y over x minus x. And I know you'll notice that I did not write the 2, y2 and x2, right? And that's how we get m. Well, let's say we know m, but we don't know our second y or our second x. We don't only know one ordered pair, right? So I have slope formula, and that equals my slope, check. So if I don't want a fraction, I can multiply something to the other side, right? Welcome to what's known as point slope form. The reason why it's called point slope form is you have a point, which means you have x1 and y1, and you have a slope. So x1, y1, and m. I absolutely love this version of a line because watch what we can do with it. Let's say we take that from above. You had an ordered pair of 2, 1, and you calculated your slope to be 2/3. Y minus the y value equals our slope, x minus the x value. Distribute. Add 1. Look at that. Now we have that y equals mx plus b, also known as slope-intercept, specifically the y-intercept form. So point slope really does give us slope-intercept form. And it's my absolute favorite version to start with because I don't have to go, okay, let me substitute y and x and m and solve for b and then rewrite my equation. I'm doing the same math like as those people would have. I'm saving myself steps. Now, general form, a lot of times books like you to get to general form. And different books call it a little bit different. So we're right now sitting in this normal, what we feel comfortable with because I can type it into a calculator. And that would be our slope-intercept. Okay, we started with point slope, and that was the y minus 1 equals 2/3 x minus 2. But a lot of books will go, and the answer keys won't read it like this. They're going to put it in general form. General form means no fractions, no rational numbers, with they'll equal 0, and your a value will be greater than 0. Greater than or equal to. It can be equal to 0. Okay, so we want to move everything to one side. So 0 equals 2/3 x minus 1y minus 1/3. My a value is greater than 0, but I have fractions, so I'm going to multiply everything by 3. 2x minus 3y minus 1 equals 0. I just put the equals 0 at the right instead of the left. Now this is what's known as general form. And you might see this version of a equation in the back of your book when you're checking answers more often than not. So we can start with a point and a slope, and we can get slope-intercept, and we can get general. So when you're answering questions, make sure that you just look at what format they're wanting it in. Kind of like in English, you have to make sure you know whether you're doing MLA versus APA format when you're doing works cited. Okay, so another way they might word a question, and it's going to give us a lot of information. Find the equation of the line perpendicular to 4x plus 6y plus 12 equals 0, and passing through five, 2. Write your answer in general form. Okay, so I'm going to go a little above and beyond, and I'm going to kind of discuss how to graph their form, and then we're going to do this by kind of rough sketch first, and then we're going to do the actual work. So let's just take care of this 4x plus 6x. 4x plus 6, ooh, that should have been a y. I thought y and I wrote x. 4x plus 6y plus 12. And I'm going to graph it, but I'm not going to use my graphing calculator because then I have to get y by itself, and who knows, I might make a mistake. So I'm going to graph this. I know it's a line, so I'm just going to get I'm going to find my x-intercept and my y-intercept. Okay, so this would be 4 times 0 is 0, so this is really 6y plus 12 equals 0. Oh, y is negative 2. 4x plus 6 times 0, so that's 0, plus 12. Oh, that's negative 3. So now I know this crosses at negative 2. Whoops. Negative 3 on the x and negative 2 on the y. Ah. Well, that's a negative slope, right? And it looks like it's going down to over 3. Okay, let me do the algebra. Let's check that out. 6y equals negative 4x minus 12. Divide everything by 6. Indeed, my slope here is down to over 3. Okay, great, that's their line, but we need to go through 5, 2. And we need to do perpendicular. Okay, so what's perpendicular? Well, that's not parallel. Parallel, with parallel lines, that would be like slanting the same. So that would mean our slopes would be equal. With perpendicular, however, they have to meet at a perfect 90-degree angle. Now, if we're doing it algebraically, our slope times our slope is going to equal negative 1. But let's look at it logically. So we need this to come in and meet at a perfect 90-degree angle. So instead of going down 2 and over 3, instead of downhill, we need uphill. And instead of 2 and 3, we're going to reverse it, and it'll be 3 and 2. So we need to go up 3 over 2. So our slope needs to be 3 over 2. So again, parallel, slope 1 is equal to slope 2. Perpendicular, slope 1 multiplied by slope 2 equals negative 1. And you can check that with negative 2/3 times positive 3/2 is definitely going to be negative 6 over 6, which is negative 1. Okay, so our point, what we care about, is 5, 2, and our slope is 3/2. I'm going to start in point slope because I have a point and I have a slope. Y minus the y value equals the slope, x minus the x value. Now, right now, you probably don't want to deal with fractions, so I'm going to multiply both sides by 2. Because it didn't want slope-intercept form, it wanted general form, so I'm going to multiply both sides by 2. That's going to give me 2y minus 4 equals 3x minus 5. Now I can distribute. 2y minus 4 equals 3x minus 15. and then move everything to one side. 3x minus 2y minus 11. So they might also ask you to verify. If I gave you the coordinates of the vertices of a triangle, they might ask you, does this create a right triangle or not? So you could graph it, yes, absolutely. Or you could go ahead and check out the slope from P to Q, the slope from Q to R, and the slope from R to P. Okay. So y minus y over x minus x, Q and R, y minus y over x minus x, R and P, y minus y over x minus x. P and Q. Make sure I did that. I wondered about that. That was supposed to be a 17, wasn't it? It was supposed to be a 17 and an 8. Y minus y over x minus x. So we have negative 14 over negative 5, or 14/5. Negative 12 over 3, or negative 4. And negative 2 over negative 8, or positive 1/4. And right here, we can see that if you were to multiply those together, you would get go ahead and get negative 1. So because negative 4 times positive 1/4 is negative 1, we have a perpendicular angle, which means we have a right angle, so yes, this would make a right triangle. So if they ask you to verify whether something's like a rectangle or something, you just need to make sure that you are verifying that you have perpendicular spots, or that your slopes are multiplying to negative 1. So parallel, your slopes are the same. Perpendicular, your slopes multiply to negative 1. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.